Good afternoon and welcome to the workshop on network management and monitoring tools. This is actually the second workshop of this kind. The first one was 1.5 years ago in Copenhagen, and I will say a bit more about it in a couple of minutes. So we are now starting with the introduction into this workshop. The first workshop was held in Copenhagen in October 2019. It was face-to-face meeting back in the good old days when we were allowed to do that. The key topics of that meeting were centered around campus network management and campus network monitoring. So we had 8 different NRENs presenting their use cases in monitoring and managing parts of their customer infrastructures, either schools or universities. We also had a presentation about the CNAS service description. We had a couple of presentations about monitoring wired wireless networks, network management, automation, and orchestration, and also about some network management and monitoring platforms. This workshop was important for Work Package 6 because it provided very good feedback to us in which direction we should go. And this was the workshop which defined the path in which Work Package 6, especially Task 3, was going in the past year and a half. If you would like to see more about that workshop, there is a link down in this slide. And of course, all these presentations are available on the event page. And one of the conclusions from that workshop, actually the first conclusion from that workshop, is that we should have more of the events of this kind. This is the second NEMMO workshop, but in the meantime, we had a couple of other events which are related also to network monitoring and management. We had dedicated info shares for some of the tools that we are developing, and there was also recently a telemetry and big data workshop, which is somehow similar in the topics that it covered. So right now we are here at the second, we call it NEMMO, Network Management and Monitoring workshop, and we will present you 8 presentations. We will show you what was done in the meantime since the first one. All this development was in Work Package 6, some of it in Task 3, some of it in Task 1. You will hear about the tools and services that are being developed in Task 3, like Persona, PMP, NMaaS, WiFiMon, the latest news from these services. You will hear something about the tool called Argus, which was developed in Uninet for alarm aggregation, and this was a part of their effort and their work on campus network management. You will see a system that was developed in the LoLA team in Task 1 about a system that is monitoring and measuring latency and jitter throughout the GÉANT network, and this is something that is used for low latency operations, like for example, joint music playing, and a part of this sub-project called LoLA. You will hear the latest update from Mauro about in-band network telemetry, and a presentation about the potentials of advanced monitoring data analysis, especially because we, in one of our products in the PMP, we have a lot of data that is gathered throughout Europe from various different measurement points. We plan to organize this workshop. It says NMaaS info share, but this is from the old presentation. This workshop in 2 sessions. The first one is supposed to last for 1.5 hours. We are now at this welcome and intro, and we will have 4 presentations in this first session. After that, we will have a 15-minute break. Since the time slots for the presentations are not very long, only the first one is 25 minutes, the other are 15 minutes, but the first one will be presented by 2 of our presenters, and we have actually 2 presentations in one. We are kindly asking you to, if you have any questions for the presenters or any other discussion topics, to keep it for this latest slot at 14:20. Also, you can ask the questions through the chat, and we will then repeat them, or you will be able to ask those questions if you would like yourself. In the second session, we will have another 4 presentations, and at the end we will have a Mentimeter where we will ask you a couple of questions about what do you think about what should we do, and how some things in monitoring and management should look like. And at the end, there will also be a time for discussion. A small info for the presenters: if you hear this sound, this means that the end of your time slot has approached. I will play this sound approximately 2 minutes before the end of your time slot. So we should try to keep everything according to this schedule. So thank you all very much for joining us at this workshop today. We have at the moment 66 participants, which is really great. And I hope that you will hear a lot of useful and interesting new stuff from all our presenters. And I hope that we will have also the opportunity to discuss some of the things that you will hear today. So I will now stop sharing, and I ask Lukasz, who is our first presenter, to start his presentation about the latest news in NMaaS and also how NMaaS is being used for rare monitoring.
Okay, good afternoon, everyone. Let me share the screen. Okay, is everything okay, Pavla? Can you hear me? Can you see the screen?
Yes, perfect.
Okay, so my name is Łukasz Batowski. I work in PSNC, the operator of the Polish NREN, and I will be co-presenting with Frederic Louis from Renater. At first, I will give a brief presentation about the NMaaS, some updates from the NMaaS production service maintained by the GÉANT project, and also give a few words about how NMaaS supports the multi-tenant model of the service. And afterwards, Frederic will do a brief demo, hopefully live, of how users can easily deploy applications on NMaaS and how they can apply the applications to some real world use cases, like in this case, monitoring of our rare project infrastructure. So basically, what is NMaaS? So NMaaS is basically a marketplace offering network management in the cloud. So basically, this is we are offering the possibility for users to easily deploy network management applications via a web-based portal, and those applications are being spawned in a dedicated Kubernetes cluster, being our cloud in this case. And also, NMaaS is a production service that has been developed actually from scratch, and at this point it is still being developed, but it is also maintained by the GÉANT project as a production service. So of course, NMaaS is offered to anyone, let's say, interested, including any institutions, some other GÉANT project teams, or even NRENs themselves. And why we have developed this? So the idea was to ease the network management and monitoring, software deployment, configuration, and maintenance, in order to allow users to focus on their daily tasks, on managing their services, rather than wondering about how to maintain the infrastructure on which their network monitoring applications reside. So basically, why should you consider the NMaaS service in your context? Maybe you would like to simply try out some applications that you don't have experience with yet, but they are offered by NMaaS. Maybe you don't have sufficient physical resources like servers or virtual machines to run the network management applications that are required in your context. Maybe you don't have the required knowledge about how to maybe set up such underlying infrastructure, or maybe how to run particular application. maybe on the other hand, maybe you have multiple customers that are asking you to monitor their infrastructure, and you probably don't have actually the time to do this. And maybe your customers do not have the sufficient resources to set up or to host the monitoring applications that would be required in their context, or maybe simply would like to focus on managing the services rather than setting up the all infrastructure around it, and wonder where to find a VM or server, how to install a particular application, and how to maintain it along the way. So how actually you can use NMaaS? You can maybe, in order to test NMaaS, just do some brief testing, see how NMaaS works, or maybe test the applications that we currently offer. So to this end, you can use the NMaaS sandbox instance that is running on nmaas.org. Basically, there is no configuration overhead. You can just log in with your GÉANT account to the portal under this URL. Later on, an administrator will be notified that a new person has logged in and will approve the request and assign you to some test domain, so that you are able to deploy your own applications or even use some demo applications that are already running on this environment. Maybe if you would like to do some actual monitoring of some actual infrastructure, then you might want to use the NMaaS production instance and the production service offered by GÉANT that is available at nmaas.eu. Of course, it is secure and fully supported. And the third option is to run your own instance of NMaaS, which is a bit more complex because you need to have a Kubernetes cluster that is running underneath. But anyway, you can visit the NMaaS installation guide that was recently updated, and I can mention that we already have some institutions interested in deploying their own instances of NMaaS, like Renater here locally, but also a university from US. And to make this even easier from the user perspective, in the near future, we are planning to do some research on the micro KAS or K3S projects to be able to fully automate the process of setting up both the Kubernetes cluster and also the NMaaS software on top of the cluster, so that you can even easily run everything on your locally on your laptop, and to have an NMaaS instance running locally. Of course, to do some basic testing and then move it to some actual dedicated Kubernetes cluster. So currently we are supporting 21 applications from various areas. We are supporting few applications that were actually developed and are offered within GÉANT, like Personar or WiFiMon, and we will see some presentations about them a bit later during the workshop. What is worth noticing is that we have recently added 3 applications like iSynga, Victoria Metrics, and even Metrics, that is instant messaging server. So this is also something interesting. And currently we are looking into integration of RPKI application named Routinator. So some KPIs from the NMaaS production service. So currently we have 95 registered users on this central NMaaS portal maintained by the GÉANT project. For those users, we have set up 19 domains. I will come back to the concept of a domain in the following slides. Basically, those are some tenant environments, and yeah, so we are supporting at this point six NRENs, 4 end institutions, and 5 other projects from the 5 other teams from the GÉANT project. And those users have currently 64 applications that are running in the cluster. So this is a diagram that shows which applications are being deployed the most. So you can see that Prometheus plus Grafana are the ones that are most popular at this point. We have some few deployments of applications like Oxidized, LibreNMaaS, the Bastion server, InfluxDB. So you can see that you can find something that will suit your needs for sure in this set of applications that are being offered. And of course, the portfolio is meant to be enhanced in the future. And the interesting thing is that actually those diagrams were taken from a Grafana instance that is as well running on the NMaaS production cluster. This Grafana instance is loading data from a Prometheus instance that is also running within the cluster. Those are the URLs under which those applications are accessible. Grafana is actually accessible publicly without any VPN, but of course the Prometheus instance is hidden. Is hidden from the public internet and is also only accessible via a dedicated VPN. And in turn, the Prometheus instance is collecting metrics from a dedicated endpoint that is being exposed by the NMaaS software itself. So I typically try to show briefly how the process of deploying new applications in NMaaS work, just to try to convince everyone that this is really a straightforward process. And maybe Frederick will also show this during his demo part. So basically, users log into the portal after they are assigned to a particular domain. They are able to select an application from the portfolio. When they are starting deploying the applications, they need to provide some basic information like a custom name for this new instance of applications. Application, in this case Icinga. They can select a particular version of the application that is being supported, and they also need to indicate in which domain a given instance of application should be deployed. Yeah, so the installation process starts right away, and along the way, once the application is deployed, we are the process stops, and the user is requested to provide some really basic information. Basic configuration for this application instance that is being deployed. In this case, for Icinga, we should provide an default email of the administrator user for this instance and the password, and also indicate how much storage space should be allocated for this Icinga instance. Once the configuration is applied, the application instance is being activated, and within a few minutes, user is able to access the new running Icinga instance under a dedicated URL. Sorry. So how NMaaS supports multi-tenancy, because this is something very important in our case. So we have introduced the concept of domains being tenant environments with isolation between environments enforced on multiple levels. So we have a domains created within the NMaaS portal itself. So you can assign users to particular domain within the domain, and the users of a particular domain you can assign specific roles like domain manager role, and such manager can add new users or manage the roles of particular users that already belong to a given domain. And with the administrator, domain administrator role, you can also subscribe to applications, and those applications become available for deployment in given domain. And of course, later on, you can deploy one or even multiple instances of given application, and further on apply configuration and have access to the applications deployed within particular domain in the portal. On the other hand, inside the Kubernetes cluster, we are using the concept of a namespace. So this is quite technical, but basically a namespace is a virtual subcluster that is being configured for each domain. So for each group of users, either maybe an institution, for example, so that the applications are not mixed between domains, and basically they don't even have access to applications running in different namespaces. And the third level of isolation is, of course, the network level, where we apply specific routing rules between the network prefixes that were assigned to both the applications deployed within the Kubernetes cluster and also the namespaces. Sorry, the network prefixes on the customer side where the equipment to be monitored resides. And of course, we are setting up dedicated virtual networks for user access to the applications, and also to exchange the monitoring data between the application and the user equipment. And we also, in addition, we are controlling the outgoing traffic from the applications that are deployed on Kubernetes. So in total, this gives a overall isolation, so that we can assure that the infrastructure set up for a particular institution is actually a private and secure for this institution alone. And just in the end, a brief diagram showing how this is done visually. So on the right we have a NMaaS service provider that runs a Kubernetes cluster. We also have some firewall in place and VPN termination server. We are currently supporting either OpenVPN based VPNs, or we are also supporting WireGuard. And for the firewall software, we are using the pfSense VM, that is software-based firewall. And when a new domain is created for example, in this case, NREN, dedicated namespace is created within the cluster. Dedicated rules are applied on the firewall level, and dedicated VPN is being set up for this particular NREN. We can do the same for institution behind this NREN. So we are setting up a dedicated domain as well, and we set up a dedicated VPN and so on. Same goes for a different NREN. In this case, also on the NREN level, it can be specified which equipment should be accessible from the applications running on NMaaS. So of course, this is only a subset of all the devices that are running within the NREN network. And most interesting scenario is this one, when for example, a particular institution have multiple physical locations, and in this such case, we can either create a dedicated domain for each particular location, or as we do for one use case, in the actual use case from NMaaS production, we can have a single domain and a VPN that is spanning multiple physical location. And we have a network engineer from Slovenia that is responsible for managing networks of 3 primary schools in Slovenia, and this is the setup that he actually has. Okay, so please feel free to contact us if you have any questions or would like to test NMaaS, or to share your own tools maybe with the community and would like to have them added to NMaaS, or maybe you would like to set up some monitoring tools on your own on NMaaS. Here are some references to additional information provided online, and I would like to give the floor to Frederick. Frederick, you are on mute. Yes.
Yes, thank you. Can I share the screen, Lucas? Yes.
Okay. Yes.
That's perfect. Sorry. So can you see my screen?
Yes.
Yes, perfect. So thank you all for being here. I will try to make this very quick. As it is a demo, it must be very interactive, and should it be of your interest. So I want you to be alive, especially that it is lunchtime. So basically, I would like to give you the context of the RAR project and why NMaaS is used by has helped us to progress a lot regarding network monitoring. So basically, the RAR project is about creating, it stands for Router for Academia, Research and Education, and the idea is to create a platform that will instantiate multiple solutions. Each multiple solution will have a specific data plane that can corresponds to some use cases that are really important for in the research and education landscape for the institution. So this is the background of the project, and so far so good. We have progressed, and we have deployed the testbed here. That starts to become very interesting. For now, it is only powered by 10 gig links. I say only, but take this as a good pinch of salt. We are just hoping that at some point we will upgrade to 100 gig, because we have some already partner like Surf. Sorry for the icon, it's not up to date. It should be Surf. Surf and Starlight who would like to move to 100 gig. So we'll see that later, but we hope that we can do interesting things with that. So far, so good. The platform is working well. We are able to run all the flavor of IGP, ISS, OSPF, segment routing, all the stuff you already know. I won't spend much time on it because you are mastering this subject. But one thing to understand is that once you deploy a platform, you need something that gives you some visibility. You need network monitoring, and this is not the main job of NMaaS. The main job of NMaaS, of RAR, sorry. The RAR project is about creating a platform, not to create a network management platform. But we need this network management platform because who would like to try out a new platform without being blind? And this is the idea of using NMaaS. It helps us to save a lot of manpower related to deploy network monitoring system that can be simply instantiated on the fly. So this is the background. And here, an overview of the lab. But in the end, it was quite interesting to see that we were able to provide a new way of doing things. Simply because from my personal experience, I'm mostly familiar to NetFlow and SNMP as a pure network stuff. But then I just discovered Prometheus and Grafana simply by curiosity. I saw it in the NMaaS catalog. So coming back to the demo, let me show you how it works. So assume that I am the RAR network domain manager. Okay, so I will use my GÉANT ID in order to log in, and then I am prompted this very nice catalog, and each square corresponds to a specific services that is used in the RAR project. As a side note, just as an answer to Ivan, yes, we can be part of different domain, and of course being authorized to deploy application for different domain. So this is, and then here I will consider the RAR domain. Okay, so in the RAR domain, if you see, you have a specific color. And what does it mean? It means that we have deployed this application, and or at least we have subscribed to it. So we have used a lot of application, and hopefully, I would like to, by the way, thank the NMaaS team for the reactivity and the way to help us in deploying all this type of application. We can go through a round of description of each application, but as the demo must be short, we should deploy. I want to show you something, how it is the look and feel to do that. So in order to do that, let's create a Grafana instance. We have already a Prometheus and a Victoria Matrix database. I'm not sure if you are familiar with Victoria Matrix, but Victoria Matrix is a very good time series database that is used and developed by the CERN. You can find it on GitHub, very highly scalable, horizontally scalable, and be ready to be integrated with Kubernetes. So as I don't want to cheat, I will put the date of today. I think it's 24, Lucas, can me correct? Can you confirm? Yes, sure. Okay, let's assume that it's, so the date of today, we will use 734, and then we are deploying it. And you are done. You are basically done. It's finished. Now it asks you to create an account, an admin account, which is very secure. I will put a very secure password. I want it to be accessible only via VPN because I don't want it to be public. But this is my choice. You can use it as and expose the microservice to the internet, but this is not what I would like. This is something I would like to avoid. So of course, Google Chrome is saying that my password is compromised, which is normal, as it is a very secure. But then there is an activation in progress. So let's put this aside. Okay, we are basically done. So here, what I would like to show you is an example of the work we have done with James Burnett and also Nael Donaghy. This is basically one of the applications that is passively reading the link state database of a network that some of you might know very well because it is the GÉANT network. So you see that we have all the nodes participating to the ISIS and their number of adjacency. When one node is becoming down, or if there is some at some point some link decrease, you will see here this one is normally using six has 6 adjacencies. If it goes to 5, you know that it is there is a problem. So this is a very good dashboard that can provide you a good way of how to, at a glance, you have an issue, you know what's happening in your network. So this is the second view here. This is, again, this is only by deploying one single router, but in terms of network monitoring, we had to tune this, and we know that for the last 5 minutes, as the GÉANT network is very stable, we have no problem at all. But what if we use the 24 hours view, and then we see some event here? And for us, for those people who are managing this network, you can correlate that these are specific maintenance or that are really planned, and considering the time, you see that it's something under control. And you will see also the impact here, the correlation between the French node, the Italian node, Ljubljana, and also in Spain. So we see that this is correlated. It's just an example, but I just wanted to show you that this is something that is free. when I mean free, there is no cost at all in order to monitor that. So let's go back to the the deployment. Sorry if it took some time. Yes, so for the deployment here, I need to find my, sorry, Lucas, and for this, but let me show you where I deployed the application. I'm just trying to find out the Windows. Oh, yes, it's here, sorry. Too much Windows, kill the Windows. So here, the application is active. You see that I have done almost nothing. And then I would like to access the application. So I'm accessing the application. And here you see there is a name here, GFN 210324, which is the date of today. So it's not something that I prepared. I have written the service name in front of you, and then I will put, of course, the very secure password that you might already know. Sorry, Chrome is annoying for that. Okay, so now we have a fresh Grafana that is empty. And the thing is that I would really like to have some graph. And as I know that I have already Victoria's metrics data source, I will define it now. Okay. So for those who are Grafana guru, just you know what I'm doing. I'm adding a data source. The data source is updated and it just works. So what I would like to do now is to create a dashboard that will, for example, will reflect the link of one of the P4 switch, sorry. So basically, I will click on import, and as we have done a lot of work related to that, we have here a dashboard that is open source. You can copy it from Grafana website, and you go there. You put here, you click on load. You select a data source, which is a Victoria Matrix database. And what happens is that you have the graph automatically. So automatically here, I just realized this morning that one of my colleagues from the RAR project decided to pursue, he forgot to remove an iPerf. And here he just decided to pour 100 gig to the P4 switch in the University of Murcia. So you see here that we have some glitch, some issue in order to maintain the counters correctly, because here this should not happen. It should be a straight line, or at least something that is not having this aspect. So my job here as a RAR pure network operator is just to demonstrate to focus on how to provide an accurate graph compared to the traffic I have to inject. Last but not least, we have a Jenkins that automates the build of the RAR image every day. So this is the pipeline, and then the result of this pipeline is that every day it creates an equivalent of the GNOS or whatever you want to compare iOS image. Here we have one install. You have the possibility with one line. You have the possibility to install a router that is able to switch 100 gig traffic. And that's it. Thank you, Lucas.
Thank you, Frederick, and thank you, Lucas, for this presentation. It was 5 minutes longer, but I think it was interesting, and also I was unfair to you because I gave you 5 minutes less than everybody else for 2 presentations in one. The next presentation will be made by Morten Brekkevold from Uninet, who created and led the development of the Argus system, the system for the aggregation of alarms, probably coming from multiple campus networks. We also got a couple of questions for Lucas and Frederick, and we will see if they will answer this in chat. If it is more convenient, we can wait for the discussion session. So I suggest that we now start with the presentation from Morten. So Morten, please, the floor is yours, and start to share your screen.
Thank you, Pavle. Can you see my presentation?
Yes.
Okay, so I'm Morten. and I'm a senior software engineer at Uninet. I'm going to talk about Argus, the aggregated alarm console. So we are in the business of NMaaS, of course. So very early on, while developing our concept for campus network as a service, we knew that one requirement was for the customer to have access to their own monitoring data and even to be able to make small configuration changes to access ports if need be. Our network monitoring solution of choice for NMaaS is our own NAV software, which already allows for this. But NAV, like many such software packages, is not really a multi-tenant system. So we quickly realized that we would need one NAV instance per customer. And this also led to the realization that if we have 10 customers, we now have 10 NAV instances. So the question emerged, how will we manage monitoring alerts coming from all these instances? Each NAV instance has its own alert dashboard and its own notification profile configuration system. And surely we cannot expect our service center to have one NAV dashboard for each customer, one physical screen for each customer. That just becomes crazy. So we realized that or the first idea was that we would reuse the existing functionality in NAV, which can process events and alerts and notifications. But even though we have successfully integrated some third-party software into NAV before, NAV isn't really designed to handle events that come from external systems. And also, it is notoriously cumbersome to configure notification profiles for end users. So we decided basically that we need something new, something that has the single purpose and the single purpose of consolidating alerts from multiple systems and provide our service center with the necessary functionality to handle incidents across our entire service portfolio. Since we were already tight on developer resources before our imminent launch of NMaaS, we started by writing a project proposal for building just such a tool. Then we have the computer science department at the local university, NTNU. They offer a course to fourth-year master students called a customer-driven project. They accept project proposals for software development, and they assign them to students so that they can gain real-world experience in solving software problems for real customers. So we submitted our proposal to the computer science department, and they promptly accepted it. And our project was assigned to a group of 6 students in the fall of 2019. If you have the option to do something like this, I would definitely recommend it. You can solve problems at low cost, maybe not at high quality, but it's a very good way to prototype things. You get to know prospective employees, and it's an opportunity to further the education of those who are essentially our end users, the students. The result of this project is what eventually became Argus. And the version 1 of Argus has been running in production at Uninet since just before Christmas. At its core, Argus is just a database of incidents, and incident is a term we've loosely stolen from the ETIL framework. It's basically a REST API to report incidents and to get information about incidents out of this database. Each instance of a monitoring service is known as a source system in Argus. So each NAV instance we have is a potential source system. Zabbix is another that we use at Uninet. Sunet, they like to use Nagios for service monitoring. But how do we get these systems to actually talk to Argus? And that's why each source system needs something we call a glue service. So you need a glue service for NAV, we need a glue service for Zabbix, we need a glue service for Nagios. And a glue service is just any kind of software that acts as an Argus API client. it translates alerts from a source system into Argus incidents. And the glue service also closes incidents in Argus when the source systems resolves their alerts. So basically, Argus doesn't have any special knowledge of the source systems that are involved. It just expects incidents to be delivered to it using the correct format. The Argus frontend itself is just another API client to the Argus server. So it exists to enable end users to interact with Argus, to see which incidents are open, and to configure notification profiles. Another type of API client that is also feasible is what we call an agent. One such idea is an agent that examines the open Argus incidents and adds information to them, or even linking incidents together based on knowledge it has, or the knowledge it can pull from other operational systems, such as your configuration management database or your inventory systems, things like that. Another simpler example is a report generator, which sends daily email reports of incidents using data that it pulls from Argus. This is something that we actually use today at Uninet. So here's a screenshot of Argus. When you log into Argus, you are greeted by the dashboard, which simply shows you the unresolved incidents that match the selected filter. So in this screenshot, I have selected a filter called NMaaS. This filters every incident that is related to our delivery of a NMaaS service. So nothing that is related to the operation of the research network in Norway is shown on this screen. And thus, forgot to mention that, of course, this supports federated login through FADE. So what do we see here? We see each line here is an incident. It has a timestamp for when the incident happened or was detected, the status of the incident, whether it's open or closed. We are just watching open incidents here and not closed ones, and whether it has been acknowledged by an operator somewhere. What is the source of the incident? So one such source here is the Mobility Master, which is the cloud control plane for Aruba access points. LokalNav is our own implementation of NMaaS for the local network at Uninet. And we have another customer here who also has NMaaS from Uninet. There's a description of each alert, and there is also some actions that you can do on each alert. So this is typically just go and see the details. And this alert has a actual ticket connection. So I'll show you this in the next screenshot. So what you need, what you want to know about unresolved incidents, what can Argus tell you? So each incident will have a description. This is the important part because this conveys to an end user actually what is going on. What is this incident all about? You have a start time for when the incident occurred. There is a duration or an end time. So if it's not resolved yet, then the duration is important. Which source system reported the incident is quite important. And if the source system is web-based, then you can also have a link back to more details for this incident in the source system. So clicking this would take me into the nav installation that generated this alert, and I can dig into the details if I like. You can also see each incident can be tagged with an arbitrary set of metadata, basically. They are sort of the powerhouse that enables you to write useful filters for notifications or reports. So you can see here, this has been tagged with the type of event that this alert had in nav, what customer this alert is related to, what was the affected host, in which room is the affected host located, in which nav location is the host located, and what customer service. So kundetjeneste means customer service in Norwegian. So this incident is related to the delivery of the NMaaS service. As you can see here, the Uninet Service Center has created a ticket for this incident. So you can link the request tracker ticket, or we use request tracker for ticket tracking. So you can actually click on these links and go directly to the ticket with the actual end user follow-up for this incident. Acknowledgements are also something useful to suppress unresolved incidents that are being worked on. So someone from our service center has acknowledged this, giving it an expiry time, and there also another reference to the ticket. And at the right hand, we have basically the history of events that happened with this incident. So the only two things that have happened is that the incident was reported by this source at this point in time, and it has been acknowledged. So if the incident is resolved, or I close it manually, for example, then there will appear a new closing incident here with my name attached. So these are basically the kinds of things you want to know about an incident. Now, notifications, they become quite important too. Not everyone is looking at this dashboard constantly. So typically we have our service center who is actually looking at the dashboard constantly during working hours, but then we have someone who is on duty or on pager duty during the night, and they need to have the most important events sent to their mobile phone as text, short messages. So you can configure notification profiles where you select a time slot. So you can configure time slots, which weekdays and which time periods you want your notifications. And you can define filters that define which alerts are actually interesting for you to receive. And then you have the option to receive your notifications via SMS or email. We have plans to re-implement some of the mediums that are already supported in NAV, such as Slack and Microsoft Teams, which we use extensively at Uninet. One thing that's I'm going to skip over very quickly is incident relationships. There is support for this in the API, but not in the user interface. So incidents may be related somehow. Incidents may have the same root cause, or the same issue may be reported by two separate source systems that just happen to monitor the same thing. Or maybe one issue is caused by the other. So these kinds of relationships can actually be added to incidents in the API and in the database, but the user interface doesn't have the capability of showing them yet. So what is the current status of Argus? It's already being used in production at Uninet with 4 NAS customers. We are currently in the process of writing glue services for Zabbix, which we use for service monitoring internally at Uninet, and for Zeno, which is the tool we use to actually monitor the research network. And of course, we already have support for NAV. We are also currently testing glue services for the Mist AI, which is Juniper's cloud-based control plane for Wi-Fi access points. And this is something we use for wireless, deploying wireless networks at the NAS customers' sites. And for ourselves and also some other NAS customers, we also use Aruba. So we have also a glue service for the Aruba Mobility Master, which is Aruba's version of Mist, basically. And these glue services are all implemented using the existing Python API access library, which we have published on GitHub. So every time we want to write a new glue service, we usually write it in Python, and so we have the library ready to do this. So going forward, implementing severity level as a core attribute is something that we have been pushing forward because we were lacking a good definition of what the severity levels should be. So this definition is finished, so we are going ahead with the implementation. We need to improve the filter implementation because the filters aren't flexible enough yet. We can't do complex matching of filters. For example, I want everything that doesn't match a filter is something that is requested very often, and we don't support that yet. And the way that notifications are actually processed and sent needs also improving, especially the bit about delayed notifications, which is something that is being requested. And then there's the actual integration with our ticketing system. So we use Request Tracker for ticketing. At the moment, if someone at the service center creates a ticket, they have to take the ticket URL and paste it into the incident to create a link. But we want a button in Argus so that we can take the details of an incident and post them directly to Request Tracker. And of course, we want this to be pluggable, so you can do this with other types of ticket systems. Not everyone uses Request Tracking. And of course, there's a lot of work going into deciding how to actually map incidents from source systems into Argus. What do we need to actually do it? And how do you handle things like, do you get a steady stream of alerts to post to Argus? Do you need to synchronize in case you lose contact with Argus? And this all depends on how the source system actually works. So this is why we put all the logic of this into the Glue services. Argus is free software. It's paid for by GÉANT. You can try it out. You can contribute. So if you have any questions, get in touch. Post your questions in the chat and we can answer them later, or you can send your questions to this email address. And here are some references to the documentation and the GitHub repositories and so forth. So you can check it out if you like. So that's all I have to say for Argus today. Thank you very much.
Thank you, Martin. And all these presentations are already on the event page of this workshop, so you can find all the links already. I mean, it's not just this couple of seconds that Martin has allowed us to see the links. All the links are in the presentation, which is uploaded on that site. Thank you, Marcus. Thank you, Martin, again. The next presentation is about Wi-Fi monitoring and the system that evolved a lot since the last NEMMO workshop. This is WiFiMon system. Nikos Kostopoulos from NTUA and GRNet will present us the latest news and what are the recent developments in this system. Please, Nikos, can you share the screen?
Hi, can you see my screen?
Yes, yes, great.
Okay. Hi all, I'm Nikos and will present you WiFiMon, which has been a service of GÉANT since 2020. First, I will start with the introduction. What is WiFiMon? WiFiMon is a tool that monitors the performance of Wi-Fi networks as experienced by their end users through an objective quality of experience approach. To do that, it combines crowdsourced and hardware probe measurements in order to provide complete insight into Wi-Fi network performance. And optionally, in IEEE 802.1x networks, such as EdgeROM, you can incorporate data from radius and DHCP logs in order to provide more fine-grained analysis. For example, depict the throughput per access point in your network. So what is the contribution of WiFiMon? WiFiMon aims to support administrators to detect throughput degradation in their networks, thus allowing them to determine underperforming areas and enhance their Wi-Fi performance. This could be done by installing more access points in your network. And how WiFiMon differs from similar monitoring solutions. WiFiMon differs in that it monitors from the perspective of the end user. WiFiMon aims to report on how the end user experiences the Wi-Fi network. And one major advantage of WiFiMon is that it does not require any installation of an app by the end user or any intervention from them. For example, you of course all know the O-class P test that requires to press a button. It has to be triggered manually by the end user. WiFiMon acts transparently for the end users. And finally, WiFiMon provides a centralized view of Wi-Fi performance and gathers all the performance results in a central database and informs the end user. For example, in the analogy of the O-class p-test, only the end user is informed by the results, but in WiFiMon, the administrator's ears is informed by the results. Sorry, I think I said end user before. It is the administrator. Now, delve deeper into the operation of WiFiMon. WiFiMon receives three kinds of data. The first one is accounting data, the second is performance data, and the third one is wireless network metrics. And WiFiMon involves 4 components: WiFiMon software probes, WiFiMon hardware probes, which are the end devices from which we collect the performance measurements, and 2 processing components, which are the WiFiMon test server, which is the component against which we trigger measurements, and the WiFiMon analysis server, or WAS shortened, which is the core processing and monitoring component of the whole architecture. So in the first step, the WiFiMon administrator has to provide some initial configuration for the WAS in order to operate. This configuration mainly includes the monitored subnets. Why we expect the administrator to define the subnets that will be monitored? This is used because WiFiMon technology is based on end users visiting a popular website in which we have injected some appropriate HTML code that will redirect him to these performance tests. And thus, the administrator has to provide the monitored Wi-Fi subnets in order to distinguish them from wired segments in the network, or users that visit this popular website from a network outside the monitored ones. So afterwards, we collect the radius and ETP logs corresponding to the monitored devices, software probes or hardware probes, are collected by the radius and DHCP servers using a file bit agent, and they are streamed to the WiFiMon analysis server for further processing. Afterwards, when an end user, whether it is a software probe or a hardware probe, visits the monitor website, it downloads the HTML code, which triggers some measurements against the WiFiMon test server. Then the end users calculate the performance results and stream them to the WiFiMon analysis server, where they are correlated with the available radius logs. They are processed, stored, and provided as visualizations to the end user, to the WiFiMon administrator. Now, some more details about the WiFiMon test server. Recall that the purpose of this component is to hold the code and test data required for performance measurements. The operation of the test server is based on JavaScript technology. So we embed some HTML lines to a frequently visited website, and this HTML lines includes some JavaScript tags, which point to the test tools included in the WiFiMon test server. And thus we we perform measurements of the HTTP service, which constitutes a major part of the internet traffic, and thus they are very indicative of the performance in the Wi-Fi network. Currently, WiFiMon is based on 3 test tools. The one is NetTest, but the major ones are Akamai Boomerang and LibreSpeed Speed Test, where you can find more information about these tools in the links included in the slide. One very important decision about the WiFiMon test server is its placement. The WTS component should be as close as possible to the monitored Wi-Fi network in order to minimize the distance between the end devices and the test server, and thus minimize the accuracy loss. This is because if you place the test server far away from the monitored network, you will see the round trip time included in your performance results. However, even if placing the server close to your monitored network is not possible, WiFiMon can still capture the relative changes among received measurements. WiFiMon, the emphasis of WiFiMon is not to report the exact throughput in a network, but more importantly, to capture the relative changes and thus inform the administrator if there is an underperforming area in the network in order to take some action, design the network better, add more access points, or anything. Okay, now let's see the end user devices. The software probes, or WSPs, are user devices, for example, laptops, smartphones, or any other Wi-Fi enabled, Wi-Fi capable device of the end user. These probes, these software probes, are used to collect the crowdsourced measurements. The crowdsourced measurements are the ones that provide the experience of the end user about the Wi-Fi in the network. And these crowdsourced measurements are triggered against the test server when we visit the WiFiMon enabled site that I mentioned before. The important thing to note here, and an advantage of WiFiMon, is that these measurements are not triggered by end user themselves. End users are not required to push a button, but upon visiting the site, it happens automatically. So WiFiMon does not require any additional software to be installed on user devices. For example, if you have your mobile phone, you are not required to install an application like other monitoring tools. And because end users could visit this website, this monitor website, multiple times, in order to regulate repetitive measurements, we use a cookie parameter in order not to overload the analysis server and the test server. For example, if you see some subsequent measurements, the cookie parameter has not expired, the subsequent measurement will be dropped. And I have included here a test page. These are the HTML lines that someone would inject to a popular website in order to trigger measurements using the Akamai Boomerang test tool. You can see here that there are some script tags pointing to the test server. This is an example test server at Suites. And you have to specify the agent. The agent is the analysis server. The test tool that you're using, for example, here it is Boomerang, and the location of the test data that you have to download. Sorry for that, I forgot to mention that the main idea behind these test tools is that the end user downloads some small images or some garbage data in order to calculate parameters such as the download throughput, the upload throughput, or the HTTP round trip time. Now let's see more details about the WiFiMon hardware probes. These probes simulate end users. They measure Wi-Fi performance from fixed points within the network. And thus, we say that these measurements complement the crowdsourced measurements by providing a baseline throughput, as the distance between the hardware probes and the access points remains relatively constant. And the performance measurements are similar to the software probes. They visit the website enabled by WiFiMon, and they trigger measurements against the test server based on predefined period for which we use a cron tab. But additionally, WiFiMon hardware probes also collect some wireless metrics. They collect data about the monitor SSID and nearby SSIDs, such as the access point, signal strength, link quality, bit rate, and transmission power. And this is an example of a cron tab. The only thing that the user has to do has to download the pre-configured image about the WiFiMon hardware probes. We provide one in the GÉANT wiki, the public page of WiFiMon, and complete the URLs about the test server. And we currently use for us probes Raspberry Pis version 3 and version 4. But any small form-factor device could be used. And finally, the server is the core monitoring component of WiFiMon, and it includes two modules: the agent that collects and processes the received monitoring data, and a UI that depicts the results of data processing. As you can see here, this has some similarities with the previous figure. You can see that accounting data are delivered to a Logstash instance, and they're transformed to the appropriate format and stored in Elasticsearch. Afterwards, these logs are correlated with the measurements available from end users. They are correlated by the WiFiMon agent, and through a Kibana, they are served to a WiFiMon user interface for visualization by the administrator. And this is an example of the WiFiMon user interface. You can see that these are results from 3 hardware probes during a period of 1 hour. On the left, you can see that these are results for all the available probes, 3 lines for every monitor probe. And on the right, you can see that these results are aggregated. The results that appear on the left are aggregated. This is a simple mean on the right side. And let me stick to one more detail about the correlation with Radius and DHCP logs. The logs are, as I mentioned before, extracted from Radius and DHCP servers using Firebit. They are processed and transformed by Logstas in the analysis server, and they are stored in Elasticsearch finally. We provide 2 correlation options. The first one is with the IP address of the end user. And in this case, we rely only on Radius logs. However, why we need the second option? The end user, the first type of correlation with the end user IP address relies on a field that the field is called framed IP address that is not always available in Radius logs. Thus, we provide a second option that is based on the MAC address of the end user. In this case, apart from Radius logs, we also use DHCP logs, and in order to correlate. And one more detail is that the personally identifiable information is we make sure that IP and MAC addresses, all the sensitive information, are TLS encrypted in transit and stored in hashed in the analysis server. So there are 2 options in installing WiFiMon. The first is the manual installation. In this case, an end institution is expected to download and install all the components of WiFiMon. And in this case, all data stay within the premises of the institution. And the WiFiMon provides total support, complete support for all the components. And the second option, as mentioned before by Lucas and Frederic, is to deploy an application in NMaaS. And in this case, some data stay in NMaaS, but you have to install the WiFiMon test server still by the institution because it has to be, as mentioned before, close to the monitor network. And ongoing work in WiFiMon is that we are currently contemplating working on an Ansible script for automating server installation, the first option. We're in a test phase and it will be available very soon. So our evaluation was mainly based on the GÉANT Boschum 2020, which monitored the eduroam SSID and used both hardware probes and software probes. In this case, the lines of HTML were injected in the agenda of the conference, and we received consent by the end users during the online registration process. And the test server was very close in the venue. It was installed in Arnes. And as you can see here, have some results from the average download throughput reported by the crowdsourced measurements. Recall that these are by the end users during the first day. You can see here that there are some visible drops or more or higher levels of throughput. For example, the first drop is indicated in the figure. There are some major drops that happened during and after coffee breaks, that presumably more people were visiting the Boschum agenda close to the to specific access points, and they overloaded them. And the second drop was during the lunchtime when most participants gathered in less space. And as you can see, there were higher levels when participants were distributed across the different sessions and overloaded less access points. They were distributed in the venue, and thus the overload on specific points was less, and the throughput was reported to be higher. Okay, these are some results from hardware probes, and you can see that the main thing to see here is that they match the drops of the previous measurements. And I will skip this slide as I see that I'm running out of time. These are some results from our recent setups in home networks. there is one probe that reports the average download throughput during 2 different days. And you can see that in the first figure, we can see there is a notable drop when I was downloading some big files from my PC, and it is visible in the network. Okay, so the future steps of WiFiMon are to enrich the toolset of WiFiMon, apart from the 3 test tools that I mentioned, contact interested RENs and assist them in installing WiFiMon. The most recent setup was in the GÉANT and NREN. Set up WiFiMon in home enterprise networks of team members to analyze the results in long term, and include the version tracking feature in WiFiMon. And here I have shared with you some links, the WiFiMon video, the WiFiMon info share, or earlier presentations. And this concludes my my talk.
Thank you, Nikos.
Sorry, I ran out of time.
But no problem. I mean, it's not a huge delay. So the last presentation for this first session is coming from Mauro Campanella, and this is the work from the task 1 of our work package. So Mauro will talk about the recent news in their work on in-band network telemetry. So Mauro, the floor is yours, and please share your screen.
Good afternoon to everyone. I'm sharing screen now, full screen.
Yes, we see.
Okay.
We see,
I have to.
We see the presenter view.
Yeah, I have to swap screen. Just a second. Sorry. I have 2 screens and I have to swap screens. In the meantime, I know I'm late and I think that everyone wants to get a cup of coffee. I will try to browse through all the slides as fast as possible, and maintaining the agenda. So this is an update of the experience we have with in-band telemetry. Why we did that? The idea is not to check another technology, but to see if another technology would be useful for the next future. And for the future, I mean, we are building larger networks, which means more protocols, LAN versus WAN, rising security threats, more bits per wave, which means that essentially the amount of bits per second is much, much higher than it was when we started using SNMP many years ago. And the point is that we are still using what I call slow monitoring. Usually we use 5 minutes averages, or we average the traffic 1 to 1,000 packets and so on. Is that enough? Can a tool be more useful? At the same time, we started looking at that also in other environments, in the open source and the public environments, and the commercial environments actually had the same needs. So they started producing 2 things. One is a programmable way for new silicon devices. P4 is the programming language, and new silicon devices are kind of new network NICs like FPGAs or the Tofino network chips for much higher line speeds. Just a short remark of what it means that you have the possibility with these technology and the programming language to check every packet is in input in your switch or router, and then you can manage the packet according to specific rules. And one example, and this is int, you can add a small amount of bytes that transport information about the switch itself or anything that the switch itself has analyzed. Small amount of bytes is usually 28 or multiple of 28 bytes per packet. It's a small overhead, but it may imply that you can really look at the details of every packet history. Then the point is that if you want to use int, what we did is that we started implementing this packet management in P4, a high-level programming language, which looks similar to C and Java, but it isn't really similar because you're really programming the hardware to do some bits handling at the packet level. The good point is that P4 as a standard is a moving standard supported by many even commercial environments, and it is supported by more and more switches, silicon switches, and also virtual switches. So we have now a variety of platforms to which it can be implemented. Why int? Well, if you think that you can have a probe in your own network, or you can probe a specific flow that you yourself generates, you can check packet routes, path changes, latency spikes, because you're really looking at the packet behavior while it traverses your switches. So you can open the possibility to innovate in some way, in the way you look at and monitor and control the network at the same time, because most of this information can be very useful to modify in real time the network behavior. And this is called self-healing networks or other things. So you can automate most of these things that are still partially manual at many layers. This is just an example, and I won't go into details, but Alibaba Cloud is using int to avoid congestion in its own cloud. So essentially he has simple and now not so expensive at all. They're less expensive switches that can direct detection of early congestion indications to the monitoring console that will then feed the control plane to change some path in the cloud itself. So this is a real example by a large provider, which is Alibaba and a large cloud, that demonstrate that this type of fast feedback loop works not just in the wide area network, but also in the clouds. This is how we implemented the int test in our network. We decided to act as an end user in two sites, two LANs, that sends int-enabled packet, int-tagged packet through our own networks. And the idea was, let's see how NRNs and GÉANT networks modify the packet flows. What we discover on the wide area environment, tagging each packet in a small flow. We used three types of platforms because we wanted to understand better the portability of what we are doing on int. EdgeCore, Tofino, and Barefoot, originally now Intel, Arista. Virtual switch also, because that's the easiest way to start, but it's a fully functional int implementation, and the NFPGA in SESNet. That's the test bed. The red dots in the rightmost picture. So it's a wide area environment in which we started sending a small UDP flow between the sites and start measuring that using the int tags per packet per flow. I have only 2 or 3 slides about the measurements. The measurement works. This is an example of a UDP flow of 1.8 packets per second is only 1 megabit per second. So it's not what you would consider a very, very high rate flow, but at the same time is as high enough to allow us to look at the microsecond level of packet handling by our own network. The good news is that we had no reordering and no packet losses. So the NRN networks works very well, and that's a very plus. But indeed, if you look at the packet inter-arrival time, there are a lot of jitters that may jitter up to 2, 3, 4 times the expected jitter. This is a type of information you can have with this very simple flow, which will not disrupt at all the hundreds of gigabit links at all. It's just a 1 megabit per second flow. This is looking at a more detailed flow, 260 kilopackets per second. We are increasing the sending rate, which means that the packets are switched at about 3 microseconds. We are just using 1 gigabit link. And what it means is that you can even look at that there are more or less a constant flow of packets with an average of 3 microseconds difference between the packets that fluctuate quite a lot, up to half a millisecond, and that's buffering somewhere. But at the same time, you clearly see some time structure. I circled in red the high level latency point, where high level is few parts of milliseconds. That is probably due to some buffering either in the sending switch or a node, which is a pizza box, a standard node, or in the network itself. Looking at the time sequence, it looks more an issue related to the sender node than to the network itself. The network is probably the responsible of the high frequency jitter of the data plane. Lesson learned, well, starting with the virtual environment works very well. You actually understand what it means programming at the hardware level. And you also understand the complexity of taking decisions on packets, which is one point if you want to innovate and understand better your traffic. BMV2 is what has been produced originally by Barefoot and is very good in virtual environment. Switches are becoming quite standards now. Aristad, Barefoot, but also Intel and others are producing switches that are capable of handling this kind of programming, and even an FPGA is a very good options. ESNet is going to use probably FPGAs to monitor these very detailed behavior of the network. We are developing also the possible implementation of int over DPDK. DPDK is a kit for standard Linux nodes that can provide you very high throughput in the node itself, in this Linux node itself, and at the same time will avoid that you start buying specific hardware with specific functionalities. Our experience is that it might be good up to 10 gig at least. It is capable of handling full rate int at the 10 gig level. Let me allow a few slides now about what it also meant for us to deal with these rates. 1 kilobit per second, if you want of packets, 1 kilo packet per second. We need to manage big data, and this is a common red wire that I've also heard in the previous presentations. What I'm saying is that you don't need just to look at the technology, you need to follow the data. The data is becoming more and more the important part of what we are doing, and the analyze of the data and the knowledge we have to produce. What it means, well, you need to receive the int information and store in a database. InfluxDB, we started simple with just one machine of dedicated to InfluxDB with enough memory, and it works fine until a certain number of packets per second. That was on purpose because we wanted just to understand if everything worked well. So it worked. We chose InfluxDB. Of course, InfluxDB, as you can see from these graphs, has some limitations, but is gratefully goes up to a very large number of packets per second. If you want to do more, then you probably have to use more complex infrastructures based on Kafka or other entities. After you store the data, you have to visualize the data. It looks that we are adopting old Grafana, so I confirmed that, but unfortunately, Grafana is not very good in all the cases in which you ask Grafana to compute and display something. If you just display something, then it's good enough. But as soon as you start having a lot of points and you really want to go down to in time to a very fine-grained granularity of time, then it has some issues. It's very slow. It starts becoming slow again. So just as an information, we use it Plotly, which is a very fast way of graphing points, much faster than Grafana, and it can be of use to many of us when you start looking at a lot of points at the same time to get the feeling of what is happening. All these graphs are something that we saw on the network, and I won't go into detail of analyzing those. Some of those are not easy even to understand, but the network is exactly there. What we have done using virtual environment, FPGA, and the Tufino chip works in any case very well up to a very large amount of packets per second tagged with int, and then we collected. We are able to do a lot of interesting analysis, even understanding what the switches are. Using, again, we are not tagging every packet in 100 gig links. That probably is not needed. Everything we are doing can be just done using a simple flow and looking at what you are really interested in. I thought it important to say that actually scaling might not be an issue. Of course, if you try to tag everything and look at everything, then you have to have a very large amount of silicon and probably very complex environment and platform to do that. But there are many ways that can suit your specific use case that you want to look at, and then can go from the left is just using better ways of programming using P4 or others, using data plane programming kit, DPDK, so improving the low layers, but you can also do things at the programming layer, like data filtering online in the data plane itself, using the int information you receive. Then you can collect the data you receive in each switch, and then you actually store counters there, and you send back the counters, not the counters for every packet. You send the counters when the counter change, some kind of asynchronous alarm, for example, which means that you can do filtering, finding strange event using threshold, data aggregation. There are interesting algorithms to do that in the data plane, and we experimented that with denial of service testing, and they worked obviously according to your scope. And then you can also enlarge the platform at the larger scale using virtualization and large clusters. So as a summary, I think that int is a very interesting technology that provides you what? A magnifying glass in case of issues, or in case you want really to understand things like microburst, specific protocols that you don't expect to happen in the network. You can look at those, and you can both work as a provider or as an end user. Even if you're an end user, you can start using in between your sites and see what happened to your packets during the flight. Of course, it requires a little bit of expertise in the programming language and some specific hardware if you want to go to higher speeds. A point about time synchronization. I think it's worth mentioning that we discovered the time synchronization at that level of precision of time is far from being trivial. 1 millisecond is fine. It might be fine for most of the use cases or your application, even of int. But if you want to go down and you want to have a synchronization to measure very precise delay or the exact event of when something happened, then probably you have to upgrade also your synchronization. the last bullet point is about the fact, and I think this is an important part of this workshop, that we'll have to deal in our experience with a large amount of data. And to deal with the large amount of data is not just storing and putting that on a screen, is actually understanding how to analyze and to process that data and to create knowledge out of it. What we are doing now in the INT group is that we are looking to produce a Docker image of a INT self-sufficient switch, so that it's possible to start playing with that and understanding, implementing that in some normal machines and sending INT information between the machines that can work in a LAN or in a wide area environment. DPDK has been is being in hold now because of the COVID. We had some issues with manpower due to COVID, and I wish that everything will be solved well, and everything will be back soon. Extended topology, yes, we would like to extend the topology to much a larger environment, so we can really understand also what our networks do to the flow that flows through that network. Big data, yes, I think we have to join forces also in that point. For me, monitoring is not just the technology to monitor, it's also to understand much better at this level what means the data we collect. Standardization also is important. You will find on the slides some pointers, which includes our own webpage, in which we collected some of these information, and I signal a white paper we just released on our experience on INT, in which you will be able to find much more information, and these are other points. And I stop here.
Thank you, Mauro. That was really interesting. Thank you. Although we saw the presenter mode slide, but I think that everybody was able to see everything properly. So now we are slightly behind the schedule, but we have some time to answer some questions. For those people who are looking at this workshop on YouTube channel after the video is being processed, I will ask Lukas or Frederick just to address those 2 points that appeared in the chat and that are not visible to those people who are looking at the video. So there were questions about how NMaaS handles software updates and data migration. So if you can just summarize what you discussed with Zenon and Morten behind behind the scenes in the chat, please.
Frederick, would you like to proceed?
Well, let me just yes, repeat what I just mentioned in the chat. The idea of NMaaS was to present the concept of a marketplace or store, or a place where you can find a network management microservices easily downloadable. And the idea of, and in that context, we just decided to instantiate some services based on the SIGNOC report. We recently, the most recent SIGNOC, a special interest group report, NOC report. So and then we had some specific need in the HAR project. So that's why these microservices are exist and are here. While using them since 2 years already, we just realized that upgrade can be done, but it must be done at the application maintainer level. So it's up to the people who will maintain the microservices that enters into the NMaaS domain to manage the update. There is two. When we are talking about update, we are talking about two things. Kubernetes is using container that is an idempotent structure. So what that means? It means that when the container disappears and you respawn it, it's the same as it was in the repository. The data, of course, are persistent because we made them persistent in using a self-cluster. But these data, some application will require data model migration, and some won't require this. For example, if you look at how Oxidized is handling network configuration, it's basically a Git folder. And if you are looking at some application related to, let's say, for example, Nav, I think it uses a PostgreSQL database. If you are changing the schema internally, of course, the maintainer will have to provide a script that will migrate this data. So this is the first thing. We hope that the community behind the application will create this Helm and Helm package. It's a package actually that is that would enter the NMaaS seamlessly. This is the first idea. That being said, not sure if you are all familiar with Kubernetes, but you have a lot of mechanisms that can help user migration. And one of the simple feature of Kubernetes is that you can run container and give your container what we call a label. We can have, for example, a version label, or simply you can create a production label and a development label. So what does it mean? It means that the two services will exist all the way in parallel. And when you would like to switch from to switch microservices in terms of upgrade, you just change the label on the fly to your container. Of course, maybe we will need to respawn it, and then it will become the development micro service become now the production service. So this is one of the mechanisms you can have. And also you have the possibility to have some what we call agent or sidecar container that will that have ephemeral duration that will help you to migrate the data. But again, you have to be to get intimate with the application and know the application very well. And this is why one of the reasons why it's not something that for now is mainstream in the NMaaS team in terms of knowledge. We are really counting on the people who will publish their software to be responsible of converting their software in container form, but also in the pod form and in the Helm form. Lucas, do you want to elaborate, or maybe with the new feature related to Helm 3?
Yeah, just from my side, it's just that we are not focusing at those aspects yet, but now once we are almost finished with a major cluster upgrade and a major change from Helm version 2 to Helm version 3, I think that the next big milestone for us will be to support such even hopefully automated upgrades that can be triggered from the NMaaS portal level. But yeah, this requires some effort, and as Frederick said, this requires to do some analysis made on application by application basis. Right.
Okay, thank you, Frederick. Thank you, Lucas. Now, for Zen and Martin, do you have any other further question about this or comment? Okay.
Sure, I can.
Yeah.
Just one question, then, and it's a very standard one. What happens when there is a security vulnerability in some software that is running in NMaaS? Who is responsible for patching that?
Very good question. Basically, if it is a vulnerability related to the base OS, it will be the NMaaS team, because the base OS is something that you have to control. Imagine you are using Fusion or Alpine base OS, and there is a serious security related to sudo there, and we will be responsible of that. However, if there is any issue with the application itself, it's up to the application maintainer to do this. But but I guess you already know this. But the whole chain is quite complex to maintain, and the idea is that we clearly try to push the responsibility to the right owner of the software. The base OS is something that should come from For example, if we are using Fusion, it should come from the Ubuntu community. It should raise a CV somewhere, and then the base OS should be upgraded, and we should be used for that be ready for that instantly. So this is, of course, this is not done automatically or automatically right now, but this is seriously something we should consider.
If I just may comment, the NMaaS team is in collaboration with the team in the GÉANT project that is dealing with the code quality and security audits. So we are tracking that these things do not happen. And so far, as Frederick said, we fortunately didn't have such a situation, but we definitely have the process in place in case something like this happens. So we know very well who is responsible for which part, who is responsible for which application. So then the one that initiated this application to be added in this, the source of this application is then contacted to match this, and until this is fixed, we have the possibility to disable this on NMaaS so that it would not jeopardize either the NMaaS system or any other systems that our users are using that are related to NMaaS, of course.
Thank you, Ivana. Just to give you an example, recently we had the discussion with the NMaaS team, with Verdan, related to upgrade the Bastion, which is the jump server that is used to connect to the P4 switch. Basically, we are using Ubuntu 16.04, that of course the LTS will, the long-term support will end soon. And we had the possibility to use 20.04 or 18.04, and we just settled in using 18.04 for the usage of this Bastion, simply because 20.04 was not ready as a pod. That's it.
Okay, thank you, Frederick. I will now stop the discussion because we have a second discussion session. Professor Maglanis, you have a question.
Yeah, I mean, let me ask you a question on NMaaS and if it can be used for educational purposes as well. And let me be more specific. We teach at the National Technical University of Athens an advanced course on network management. And that supports also a laboratory that we do emulation studies and so forth. So far, we've been mounting virtual instances and emulate environments on American universities through GÉANT. So, you know, my question is whether we could switch into something like NMaaS, and I'm talking about a population of about 30 students, quite advanced students. They know their networking, they know their Python and so forth. But so far, we've been forced in a way to work with American universities. So we've been, in effect, mounting something like 30 instances. And perhaps because of the lag of timing and so forth, you know, we've been fortunate enough to get virtual machines and open flow switches and things like that mounted in several American universities and play with them. My question is whether there is any experience on using NMaaS for this kind of educational experiments, and if it's possible to conceive such a thing.
Well, NMaaS is production grade. It uses Kubernetes that is really robust. And now the thing is that you have to identify which tenant you would like to have. And if you have a certain high number of tenants, it's not an issue to have one cluster in Athens. In that sense, you have to deploy your NMaaS cluster using Okeanos, for example, resources, and you have the master in one VM and the workers in the other VM. And as you have Okeanos, I'm not sure how many VMs you can have, but you can have, for example, 1,000 VMs. That will be 1,000 workers piloted by two masters related to Kubernetes that will manage this instance for you. That being said, you have possibility to have multiple portal or one portal. We advise to have only one portal and use multiple domain because it's the best way to segment I would say the routing. And we are using BGP inside the cluster. We are using Calico BGP route reflector, and BGP policy is well established. And we have chosen BGP simply because our NOC and everyone in the NREN community knows BGP, how to operate BGP all the way to the container. So it is easy, that's the reason why applying a prefix list, a network policy on an ACL is something quite easily to segment the traffic. Does it answer your question? So yes, it's possible.
Okay, let me just ask one more question. I mean, is there any limit to your experience on the number of tenants that could be supported in a cluster like that, or are there any security concerns that you will have to deal with?
Okay, security, this is something you have to check every day. So it's like every Unix. So basically, this is the first thing. The second thing, I will give you some rough number that I knew perfectly 5 years ago, because I was really into the developing also the NMaaS concept. I'll give you an example. In the US, I have discussed with some companies that deploy a cluster with 70,000 pods. 70,000 pods, which included it's up roughly 10 pod per workers, and one worker is one VM or a bare metal server. So if you have a big bare metal server, you can put maybe 50 pods, so 50 containers. But this is the rough idea. Now, if you want to have, if you can do a lot of things related also to federation. But in order to be simple, one cluster, you operate one, and then you can dedicate some, I would say, namespace to the domain. Instantiate a new cluster when you are really confident, because migrating from one cluster to the others is not that difficult, but it will take some time. It's like as if you are migrating from OpenStack version to another, which may be something you already know with OKRs.
So regarding your first question, we also have a sandbox instance for NMaaS, but we also agreed to have this meeting on Friday, so we can maybe take a look into more details for this particular use case. But for example, for this, what you mentioned, that you might have students that would like to play with this for a certain period of time, then maybe this sandbox instance might be a good solution, because apart from that sandbox instance, there is also a production instance, which is aimed at those that want to install and use it on a longer term to monitor really some specific network that they have. So both options are possible and provided by the team. And there is also a question from Indrek. Does NMaaS plan to add some NetFlow viewer also? So at the moment, we didn't have such requests. And since earlier, we actually realized that whichever tool we wanted to add to the platform, it worked. So we didn't want to start adding yet another tool and turn NMaaS into some form of app store or something. So when there is some specific use case, and when we do know some specific users that want to use it, then the team starts to work on this. So if you can maybe contact the team for this further discussion to see which exact use case would you be interested in, I think that would be the best way forward.
Thank you, Ivana. The idea is really to have a tool that is used. If the team is randomly adding any type of tools that might be of help, and that is and there is no users, indeed, we will lose a lot of time and manpower. So Lucas, during the presentation, did present you some histogram with the usage. You see that Prometheus and Grafana are popular, but some are maybe not so used or so popular. And maybe in the long run, we'll see that we will have a trend. We can identify the trends. For example, people will use, for example, more Victoria metrics than Prometheus, and then we can get rid of Prometheus. It's not a problem, because Victoria metrics is doing the job very well. So it helps us to share this vision all together. And once there is someone who would like to port an application, for example, if Indrek, you want to port a NetFlow viewer in NMaaS, you can do it, and instantly it will be available for everyone. And that's the hidden power of I would say, behind the scene. It's not something it's not rocket science, but this is the idea. We are mutualizing experience. And once we have put some effort in putting something into NMaaS, we can share it instantly with everyone without doing much effort, because it's published.
Okay, thank you, Frederick. Now I will have to stop the discussion. We are 25 minutes behind the schedule, so I think we all need a little bit of break. Now it's 4 minutes. It's 14:56 Central European time. So let's do a 14-minute break and meet here in this Zoom room again at 15:10 Central European time, or 16:10 Athens time, or 14:10 London time. Yeah, I would also like to ask all the presenters to remain till the end of this workshop, because maybe we will have again some discussion on the presentations from the first session in the second part of discussion. So thank you all. I will now stop recording this first session, and then we will see if we are switching to cloud recording.